So what we're going to talk about to finish off today's lesson is some applications of plane mirrors and of reflection. All right? We've just talked about mirrors, and when you look into a mirror, you can see a very nice, clear image. When you see a nice, clear image, we call that regular reflection. All the rays bounce together off of this nice, shiny surface. I do want you to draw a picture like this. The way you can draw it is very simple. And you don't need to use your ruler for this. Just draw a mirror, put some marks on it, and just draw a couple of rays bouncing off. Try to make angle I equal to angle R, but keep all the rays together. It's bouncing regularly. Okay? Shiny surfaces, the light tends to follow the law of reflection. I'm going to add one thing here. A clear image can be seen. Tell me some things that involve regular reflection other than a mirror. Where do you ever notice this? Yep. Periscope uses prisms because they're a little different, but we've got toy periscopes, and those toy periscopes use regular reflection, and I'm going to show you them in a minute. I got a whole box of toy periscopes, but when you look into it, you can see a nice clear image. Correct. Yep. Yeah, metal. Like any type of metal, like this chrome surface. Even though it's bent, if I look closely, I can see my face in there. Okay? And that's regular reflection. Even a piece of glass, you can sometimes see your reflection a little bit in there. You know what I'm talking about? That's regular reflection. Okay? If it's not regular reflection, the other type is called, oh, we've already got that written down, a clear image can be seen. The other type of reflection is called diffuse reflection. Okay, and I'm going to show you how to draw the picture. Diffuse reflection is when light hits a rough surface. The wall is a rough surface. Our skin is a rough surface. The chalkboard is a rough surface. And when light hits a rough surface, the light gets scattered because it's bumping into that rough surface. You don't see a clear image. If you're going to want to draw a picture of this, draw a really rough surface, all right, and have the light rays bounce in all kinds of different directions. The rays spread out when they hit them. So when you look at the wall, you don't see your face, but you can see the wall because the light is spread out and it tells you where the wall is. Now there's an interesting little effect that takes place that you may have observed before. If I get some stuff off of my desk, and when I teach light, my desk is chaos. If I were to get this stuff out of the way, and I were to use the desktop here, actually you guys are writing, this is interesting, so I'll wait for you to finish writing. Oh, your distances weren't quite exactly. No. But that's okay. It's the theory behind it that's the most important part. So, diffuse reflection. Desktop. I look down at the desktop, I don't see any image whatsoever. It's a rough surface. So when you're looking at the desktop, you're right, you can't see any images. But if I were to crouch down and get really close to the surface of the desktop, you should be able to see my eyeballs kind of floating there above the desktop. Do you see it? Because if you think I look funny, I just see floating heads, pairs of floating heads. And that's because when the light is grazing, it bounces off all of the tops of those bumps, and it becomes like regular reflection, and we can see images. And you may have noticed this driving down the road. Have you ever noticed sometimes it looks very reflective? That is a situation where you get down to a low surface, all right? So that's kind of neat. Okay, so we either have regular reflection, you can see a nice clear image, or we've got diffuse reflection. Let's now talk about some applications of plane mirrors. So at this point, we want to talk about where do we use plane mirrors? Yeah, in the bathroom, of course. Oh, yeah, we're under lockdown conditions here.
Is Tyson here today?
Tyson is. You're taking him right now?
I would like to take him right now, please.
All right, Tyson, you're going to have to watch the video. Okay. So you're going to have to watch the tail end of the video there, Tyson. Applications of plane mirrors. Toy periscope. Draw that up, and you can put it as a sketch. Thank you, sir. Actually, 1 second. 1 second. That's going to be collected at some point. So, hey, just relax. Just relax. Let's go, folks. Let's go. Let's draw that. So, in a periscope, and here we've got one here. There is a mirror down here at 45 degrees. It's a little plastic mirror. There's a mirror up here at 45 degrees. And when you look into the periscope, I can see you guys, and we'll have a look at this in a moment. You can see a nice clear image. And that's because it undergoes two reflections that looks like this. You don't need to use your protractors for this. Let's take a ray. It's going to come in and hit it. Which way is that ray going to go? It's going to go down. Where's that ray going to go? It's going to go across. And it's going to enter into my eye. And I've got big eyelashes. Okay? Now, the reason it goes straight down is because if I were to draw a normal on here, and I used my protractor, what angle is in here? 45 degrees. And if it goes in at 45 and out at 45, you've made it turn 90 degrees. You've made it turn a corner. So 45 and 45. Let's have a ray come from the bottom, go down, enter in there. Again, two rays are entering my eye. My brain is able to project that back to a location, and we see the periscope. Let's take a look at some interesting things about the periscope. So I don't know if I've got enough for each. There's 3, so you can share a little bit. There's 3, so you can pass it around and share a little bit. There's 3, so you can pass it around and share a little bit. There's a couple of them there. Looks like I have plenty of them here, so there's plenty there. There's one there. Here's an extra one here. Here's an extra one. Here's an extra one here. What's the size of the people or the things that you're looking at compared to if you look straight at them? Tiny. And the reason it's tiny, listen folks, if you can just listen, the reason it's tiny is because the rays have to travel further, right? And if someone's far away from you, their rays have to travel further. Your brain interprets that as being small. So because the rays have to travel further, it's tiny. Notice what happens to the size of them if you shorten up the periscope. What happens to the size of them as you shorten it up? Yep. They get bigger because the rays aren't traveling as far. What happens if you try to look over your shoulder? What happens when you look over your shoulder? They're upside down. And that's because the rays get flipped upon the second reflection. All right? The rays get flipped upon the second reflection. We've got one more thing that I want to talk about before I give you the worksheet. Actually, one last kind of weird thing to do and I don't know why I tried this. If you turn it 45 degrees, and you have two of them, and you put one into the other, and then you look into there, what are you looking at? What are you looking at? Which eyeball? Which eyeball? Which eyeball would you be looking at? Each one would be looking at the other eyeball. That's a little trippy, don't you think? Looking into your other eyeball. That's just weird. Yeah. What do you got? Question? Statement? You just think that's a weird thing to look into your other eyeball? Let's write this down. Last thing I want to write down. How many have noticed that when an ambulance goes by that the word ambulance on the front of it is left and right? Why do they do that? More detail, please. I don't know what that means. What about it? So, your rear view mirror has everything inverted. You've noticed that before, right? So if you raise your right hand and you think about flipping around, it's your left hand. If you're looking at the image from the image point of view, we call that lateral inversion. Rights become lefts, all right? So when you look at the word ambulance, that is written backwards on the hood of an ambulance, in your rear view mirror, you quickly see the word properly, ambulance, and you don't have to, your brain doesn't have to think about lateral inversion in order to get it straight. Now, an interesting effect, and this is kind of neat. If you take two mirrors and you put them together at 90 degrees, then you get an interesting effect where the light bounces in and comes out. It's kind of like the two periscopes put together. But if you put them at 90 degrees, and here, I'm actually going to be able to show you this. Let me show you this, and I'll switch that back for a minute, but let me show you the input here. Watch here. So I'm going to now hold this so that you can see me. Can you see me? Are you kidding me? You've got to be able to see me. You can see my eyes, can't you? See, can you see my reflection? So like if I wink my left eye, or if I wink my left eye here, wink, wink, wink. Which eye winks? The right eye does, doesn't it? Right? So I wink my left eye, wink, 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 and my right eye winks because it's laterally inverted. But watch this trick. If I take two mirrors like this and I put them at 90 degrees, and now I look down the center. Can you see my face again? Right in the middle. How about there? Now watch. If I wink my left eye, I'm trying to get it straight in the middle. I'm struggling. Is that not in the middle? You can't see me? Now I'm going to wink my left eye. Which one winked? Which one winked? Could you see it? My left one winked. When you put two mirrors together like this, it cancels out the lateral inversion because you have a flip and a second flip. So if you ever see someone that has maybe got a bathroom that has two mirrors that are 90 degrees in the corner of the room, the lateral inversion will be gone because you've flipped it twice. That's exciting. Okay, that's the end of this. I am going to stop my recording, but I'm now going to give you a little worksheet to work on.